welcome. We're going to talk about completing the square, right? We're going to talk about what it means geometrically so that you understand why in the world you're doing some certain steps algebraically. Basically, completing the square is not a very difficult task. It is very quick and simple to do algebraically, but if you have no idea why you're doing it, then it just becomes some random more math junk that you have to remember. So let's talk about what it means geometrically so you can have this visual image in your head when you're doing this. Completing the square, let's start off with x squared plus 8x. What this means geometrically is that we have a square that is x by x, so that the area of this square is x squared. Okay, and then we have a rectangle which has the same distance on one side, which we will call x, and the other side we're going to call 8. And I've drawn it much longer than x just for fun, but we don't really know what x is, so it's just all relative. Okay, now what we're going to do is we're going to break this rectangle here in half. Okay, and the way we're going to do that is, I've already done it. I'm just going to send it behind. Look, it just disappeared. How about if I just get rid of it for a minute? Wow, it doesn't want to get rid of it. So let's just make it go away. Let's delete it. There we go. Goodbye. I have now broken my rectangle in half. And so once I've done that, this is no longer 8. This side is now 4, and this side is 4, and this side is still x. So the area of each piece is 4x. And if you notice that 4x and 4x will make 8x, which is what I want. Now what I'm interested in doing to complete the square is to add a term so that this expression is a perfect square. Algebraically, I have some value squared. Okay, now here's how I'm going to do this. I'm going to take the x squared part. I'm going to put it here. So this was x by x still. I'm going to take one of my rectangles, let's say this one. I'm going to drag it down. I'm going to line it up right next to this rectangle right here. Let's say there. And again, that area was 4 by x. Then what I'm going to do is take this other rectangle, drag it over here. Now it's not going to line up unless I turn it around. So let me spin it around here and attach it to the bottom of this one right there. And we now have a rectangle that was x on this side and 4 over here because it got spun around. Now what I want you to notice is that this side right here is x plus 4. And this side right here is x plus 4, which would be perfect if I just had a square that was x plus 4 on both sides. But in what I'm missing and what I have to do, and hence the name of this whole process, is to complete the square or complete what's missing. I need to find that yellow spot. Well, it's 4 over here and it's 4 over here, so the area of this spot is 16. So if I go back to my original problem, if I were simply to add 16 to my original expression of x squared plus 8x, I would have a perfect square that is x plus 4 on both sides, so I would have an expression algebraically that is simply x plus 4 quantity squared. Now the geometric argument falls apart if the sides are negative, but we won't worry about that for now. The algebra is the same. Where did I come up with 16? I basically took my original rectangle of 8 and cut it in half. That was 8x. So I took half of 8 and I got 4. And where did the 16 come from? Well, if the 16 was the area of this little square that was originally missing, so that is just 4 squared, which turned out to be 16. So 16 is what I ended up adding to complete the square, but the 4 is what I end up with inside of my parentheses algebraically to complete the square. Now, okay, so what happens then if I have an expression that looks like this? Let's say I have 3x squared plus 7x plus something to complete the square. Well, completing the square does not work if this coefficient of x squared is not 1. So we're going to make it 1. Okay, and the way we're going to make it 1 is we're going to factor out this 3. So we're going to take out a 3 for my entire expression. So that's going to be x squared plus 7/3 x plus something. And now it's a little nastier because my b value is a fraction. I don't really want to draw rectangles and squares my whole life, so the algebraic steps were to take half of my 7/3, and I ended up with 7/6. And then I'm going to square 7/6, and I get 49/36. And that is what's going to be added to my expression in order to complete the square. And what my final expression then is 3 times something squared, it's going to be x plus this 7/6. And there we have it. I have now added something to complete my square and taken it one step further to factoring the entire process. Now, okay, let's take a look at how this works and what this means for us. Well, we can actually use completing the square to solve equations. But let's do this in general. Let's say we have ax squared plus bx plus c equals 0. Let's say that I want to use completing the square to solve the problem. Well, all I have to do is get my coefficient of x squared first off to be a 1, not an a. So I'm going to divide every single term in this problem by a and make it smaller. Now I can do it this way because I'm solving an equation, whereas before I had to factor the a out. But solving the equation is going to be a little easier. So I'm going to get plus c over a equals, and 0 over a is just 0. Now I only need the first two terms to complete the square, so I'm going to move the c over a to the other side as a negative c over a. And what I'm going to do now is add something to this side to complete my square. But if I add something to that side, I have to add something to the other side because it's equal. And there's an equation here. So how do I figure out what to add? Well, I simply use the process of completing the square. I'm going to take half of that term, b over a, and I'm going to get b over 2a. And then I'm going to square it, and I'm going to get b squared over 2a squared would be 4a squared. I'm going to square the 2 and the a. So that is what I'm going to end up adding to both this side and the other. All right, wasn't that incredibly impressive? Well, but what good did that do me? Well, now that I've completed the square, the left side of my equation is a perfect square. So now I can go this way, and I'm sorry for the mess, but we're going to end up with x plus b over 2a, that was this term right here, squared, that's the left side, equals this all added together. Now, I would love to be able to add it together, so what I need is a common denominator. On this side, I have an a, and on this side, I have a 4a squared. So what I'm really needing is another 4 and an a on the bottom of the first fraction, because a times 4a would give me 4a squared. So I'm going to multiply the top by 4a as well. And that way I have 4a squared as my denominator. And in this case, I have negative c a, or times 4 times a, plus b squared. I'm going to choose to write it as b squared minus 4ac. And some of you might start thinking, like, hey, this sort of looks familiar. Well, to solve a quadratic equation here, we're going to take a square root of both sides, and it's going to cancel my square root on this side, basically, and I'm going to get x plus b over 2a, but I'm going to end up with plus or minus the square root of this other fraction. The denominator can be square rooted. The square root of 4a squared is simply 2a, but the numerator, I'm not going to take a square root because of the minus sign, so I'm going to have b squared minus 4ac. And then to solve for x, I'm simply going to move the b over 2a to the other side by subtracting it, and I'm going to end up with negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And lo and behold, that should look very familiar to all of you. That is what we call the quadratic formula. All you'd have to do is notice that they both have the same denominator. So we can put the entire thing over 2a, and we end up with a wonderful result using completing the square. Okay? Piece of cake, not too hard, a little messy in the algebra part, but the whole point is just to use completing the square to solve a problem, and we can do it. Now, the end result, of course, is just the quadratic formula. So completing the square and quadratic formula will always work as long as there are real solutions. And when they're not, you'll find the imaginary ones, because they're pretty much exactly the same process. Okay, so that'll do it for completing the square.